I'll be talking about whether we can learn anything from how intelligent behavior manifests in natural systems to maybe gain insight and make progress on problems in AI alignment. So the outline, I'll start with a bit of a meta perspective and then sort of go more and more into detail. So I'll start with sort of a high-level view on like the epistemic landscape of AI alignment. I'll sort of look a bit from a sort of philosophy of science perspective at what's the shape of this problem, and from like understanding some things about the shape of this problem, maybe learn something about how different epistemic strategies might help us make progress on alignment. And then in the in the third part, I will dive in a bit more detail into like one of these strategies that I'll discuss a bit more, and we'll discuss some examples of like research that could be done there or that is being done there in some more detail. Now I'll wrap up. Cool, so high-level view. You all have, I guess, by now talked a bunch about what the problem is that we are interested in solving here. I guess like very quick, very abstract summary is something like, looks like we are building ever more ever stronger sort of learners or like optimizers, and if we unleash them into the world, we might be worried about what might happen. Risks might come from that, they might be bad, and we don't currently know how to like create such systems that are like strong optimizers, have maybe some sort of autonomous goal-directed behavior without potentially like killing everyone or like making very bad things happen. So that's the problem. And once we buy in that there is a problem, that there might be a problem that we want to take seriously, sort of the next question we definitely want to be asking is something like, well then, how can we make progress? And I think that is sort of essentially a question that philosophy of science, epistemology might have things to say about, which is sort of the first part of my talk. And in particular, I want to focus on what I would like to call a sort of epistemic challenge that is inherent to AI alignment, and that is maybe like different to some other problems we sort of try to tackle in science and engineering a lot. So there's various like epistemic characteristics of alignment that I think are interesting, but the one I want to focus on for this talk is what I will call the problem of epistemic access. So essentially, the problem is something like the system that we're like most interested in studying, namely some very advanced artificial intelligence systems that might pose risks. Like those systems do not currently exist, which means that we can't use the same, like we can't straightforwardly use the same methodology as we like usually do in science and engineering, where we usually have some sort of direct access to the system. We can like do trial, like we can do experiments, do sort of trial and error, but that's not really possible in alignment. And then, like, what do we do with that? Like, how can we still make progress? And that's sort of like the question that I'm like asking when I go to the next step, which is, what are different epistemic strategies that we can deploy in view of this problem that I just outlined? And I want to introduce, I'm going to introduce 3 epistemic strategies, sort of a high-level view of like the landscape and like what different approaches are being used. I just want to caveat before I go into more detail here that this is like one way of carving up the space. There's many other ways one could carve up the space too. They're like useful for other things. The way I'm carving it up here is like with respect to this problem of epistemic access. And the different strategies sort of give different answers to, well, given we can't look at the system we're interested in directly, let's use X, or let's do Y. So these strategies are trying to tackle that challenge particularly. And in order to introduce these different strategies, I'm like going to help myself to this metaphor conceptual crutch, which I sort of want to introduce this like notion of like A space or D space of all possible intelligent behavior. This sort of some abstract space of like all the possible intelligent behavior that we could potentially manifest or they could potentially be manifested. And then like making progress on AI alignment is like roughly equivalent to understanding what that space looks like and understanding how we can navigate through that space. And my three strategies that I'm going to introduce are sort of located in different places within that space. So the first strategy I want to introduce, I sort of the tinkering. What do I mean here? So basically, the epistemic access problem, we try to circumvent that, maybe partially, by looking at currently existing ML systems, sort of state-of-the-art ML system, what we currently know how to instantiate in ML systems. And we then say, OK, cool, like, sure, like, this is not exactly what we're worried about, but we believe that there's sort of some meaningful generalization of insights that can happen when we study currently existing ML systems. And once we use this proxy, we can now go back to sort of using empiricism, using experiments, tinkering around with these systems, seeing how they might currently fail, seeing what it might look like for them to be safe, and then like hoping that some of those insights will generalize or translate to what we're like actually interested in. So in my picture here, one space within So one space within the space of possible intelligent behavior is this like subspace of what we currently know how to manifest in ML systems. And then we sort of try to push the boundaries there and try to like play around with that. And that's what I mean by the first epistemic strategy here. So we're sort of exploring the boundaries of intelligent behavior as we currently know how to implement it. Some examples of what this looks like. There's lots of work going on here. This is like roughly what like people usually refer to by technical AI safety work. So yeah, there's like a bunch of resources I'm linking here. This is like only a short sample. But that's my first strategy. My second strategy is what I call idealization. Here the idea is that we start from idealized frameworks of reasoning, idealized frameworks of like rational agency, and sort of looking at the limits behavior of what we would expect such systems to do, and then sort of extrapolate from there what like the possibility space of intelligent behavior is, and like how an idealized agent would maybe behave, how an idealized agent would maybe turn out to be risky or unsafe, and like maybe what it would look like for an idealized agent to be safe. So in my picture, the arrows here depict some sort of like far at one end of the spectrum, sort of in the limits of this entire space, we find idealized agents, idealized rational agents, idealized oracles, and we sort of study those, and again hope that like insights from this sort of first principled reasoning will again transfer in some ways to like what it would look like to make the actual AI system safe. Examples here, so you might be familiar with some of this. So this is like usually related to work in formal epistemology, decision theory, agent foundation might be a term some of you are familiar with. Maybe like power seeking in optimal agents, like first understanding the optimal case and then like trying to think about what it would look like in sort of real manifested agents. That's the sort of work that I mean here. And then the third strategy is the idea of like looking at how intelligence behavior manifests in the wild or like in natural systems. So here the idea is to look at behavior in natural systems and then like hope that we can learn from that for like designing or understanding behavior in artificial systems. Again, back to the chart here. So like this is sort of some illustration of like examples of like what we might describe as intelligent behavior in natural systems. Maybe brains, maybe animals, evolution, institutions, social systems. Maybe they depict some sort of intelligent behavior, and we want to like learn from that about like intelligent behavior in general. So here we chart out the possibility space of intelligent behavior by investigating how it manifests in natural systems. And there's maybe more to say here about like what are really the epistemic underpinnings of like why one might think this approach could be promising, or this approach, like sort of this analogizing might bear actual insights. I'm not going to go into this in as much detail because I wanted instead to provide more details of like what this work could actually look like concretely. But just sort of mentioning one idea, I think there's one underlying intuition that like does a bunch of heavy lifting is something like some sort of like realism about intelligence. And by that I mean some sort of like sense that like intelligence, intelligent behavior is some like real thing that like actually follows a specific set of principles, is like governed in specific ways, and maybe there are differences between intelligent behavior as it manifests in different types of systems and different types of substrates or modalities, but also there will be similarities and analogies and like shared principles, and we can sort of gain substantive insight into what's up with intelligent behavior. There are examples of this work as well. Some are sort of slightly more, slightly sort of more paradigm examples and slightly more marginal examples, but like just pointing at some work. So we have work using the analogy from human brains. So for example, work by Steve Bryans. He's like been looking into neuroscience and other brain sciences a bunch, and like is interested in how that might bear insight into AI alignment. We have analogies from like sort of real world agents more generally, maybe like statistical mechanics, maybe like complex systems, social system analogies, and analogies from biological systems, like Mesa-Optimizer. There's some intuition there about how the same phenomena might appear or like might have appeared in evolution. So there's some sort of inspirations that already are being drawn from by looking at natural systems. Cool. So what I will do next is dive into this like third strategy with a bit more detail, a bit more sort of concretely, what could research in this space look like, sort of go a bit more into concreteness and detail. Before that, I just want to check any questions, confusions, things you would want me to clarify before we continue. Cool. What's the time? Okay. So, studying intelligence in the wild. Now, first thing I want to say is that this is a huge space, right? Like the natural world, in fact, is very big. There's very many fields that try to study and understand the functioning of the natural world. So even if I'm like saying this is like one of 3 epistemic strategies, in fact, there's like lots of space within that strategy. And what my colleagues and I have been working on is trying to like maybe put a bit of structure into like how we could think about different ways of learning from natural systems. And there's sort of some sort of like research map that we are working on that is sort of in progress to just like help us orient in this bigger space. And I'll like pull out some examples of that research map. So yeah, before that, very quick recap. So what's the proposed epistemic bet here? Well, we want to study parallels between intelligent behavior as it manifests in currently existing biological and social systems, because we can actually go and look at them. Like we actually don't face the problem of epistemic access in the same way. And want to see whether this informs the study and design of future artificial systems. So that's the epistemic bet, the epistemic strategies. And now what might this look like? So here's sort of 6 different clusters that we are currently thinking about. I will mention all of them, but I don't think I have time to like discuss all of them in detail. I'll in a second get sort of a hand pull to like see what sort of fields or like interests are prevalent in the crowd. So I might be able to like tailor my choice a bit to like what might be more interesting to you. But I'll first give you an overview. So what are different ways we could be looking at this? So there's mind. We might want to draw from how mind and cognitions work. There is evolution and biological systems, a bunch of parallels we might be interested in exploring there. There's this sort of general thing of like, man, there's like pretty interesting and confusing things going on when we like look at systems that exhibit autonomy, that exhibit goal-directed behavior, that exhibit what we sometimes call agency, although we don't really understand what that is, but like maybe we can like make progress in understanding what that is. We have social systems, coordination in multi-agent or sort of hierarchical system where there's like different levels of agency going on. And then there is different processes of knowledge and normativity. So like the scientific process is like some sort of thing that seems to be producing insight and problem solving and knowledge. What's up with that? How does that relate to alignment? And then there's safe interfaces, which is, I'll probably talk about this. Questions of like, there's a specific type of way we might want to align AI systems with what humans want, roughly speaking, different ways of doing that. What are like interfaces we can build between AI systems and humans that are safe, that do not fall prey to a range of like failure modes we already notice now, and like, can we draw from maybe the brain sciences, philosophy of mind, maybe a sort of social sciences to get inspiration for like how to maybe design interfaces that are safe. So that's a very quick overview. What I want to do now is get some hand polls. So the question is, I'll ask for like a few different clusters of sort of domains. And would like you to put up your hands if you either have like a background in this field, maybe have like a degree or whatever, or if you like have some sort of like meaningful active interest in this, like you might have been reading up even if you do not have a degree on this, but have a sort of interest in like that field. So first might be sort of brain sciences very broadly, including neuroscience, cognitive science, psychology, philosophy of mind to some extent, anything that has to sort of do with mind and cognition. Hands up. Cool. Next category is something like things to do with social systems. That might be just social sciences, economics, computational social science, legal theory, stuff like that. Cool. What about complex systems, cybernetics, like things in this space? Not that many. Cool. What is another thing? Oh yeah, and then like biological systems, evolutionary theory, ecology maybe, biology. Cool. Okay. Sweet. Okay. Well, I think I will start. What is the first one? Well, no, I think this is a good one to introduce. Okay, the first one, the first sort of cluster I want to introduce is, we titled it Evolutionary Selection for X. Why do we title it this way? Because the core idea is here to understand the relationship between, on one hand, selection pressures, on the other hand, sort of like various desirable, undesirable properties that entities under selection might be developing or not developing. And we sort of want to draw from insights from evolutionary theory, insights from our understanding of how evolution dynamics work, to maybe understand how that might happen in AI systems too. So like an underlying assumption here is like something that sometimes is called like universal Darwinism. So some notion of like, cool, we like know something about Darwinian evolution in biological systems. It does very much look like other types of systems also exhibit something like Darwinian evolution. Maybe it's not exactly Darwinian evolution, maybe it's not a paradigm case of Darwinian evolution, but there are parallels, like people talk about cultural evolution to some extent, or we could think of sort of search in like large parameter space as looking something like, or having like similarities to Darwinian evolution. The way I want to frame this cluster, and maybe there's like some things I'm overlooking here, or like other things that are like also interested in this cluster, but the way I want to frame it right now is something like, while we usually typically look at, or like ask the question of how do we design an artificial agent that is safe, another question we could be asking that is sort of related but somewhat different is how could we design a training setup for which we're like confident that at the end of the training, whatever agent comes out of that will be safe, or will not have certain properties like being deceptive or something like that. So like the outcome, the hope here is that the like outcome is equivalent, but the tools we could use to like shape that sort of agents that we're interested in is different. And when we use that angle, we can then draw from evolutionary theory for like insights and concepts. So some example here might be things like basins of attraction. Like evolutionary theory talks about bases of attraction, which is like some phenomena of sort of convergently selected, convergent evolution, like where within sort of a quite large space, you like just end up a lot, like it end up most of the time, you like end up developing this property, so it's convergently selected for. Like how does convergent selection happen? How does this function? Can we, if we properly understand it, maybe we can draw on this because we want to convergently select for whatever kind AIs, honest AIs, who knows? Or the opposite, like, or we might be worried if we're like, oh, then I think we're like convergently selecting here for like power-seeking agents or something like that. So that might be one analogy. Another one is evolutionary transitions. So here's like things about when we look at evolutionary theory, we sometimes see something that looks like phase transitions, like going from unicellularity to multicellularity, like what's going on there? How did that change the evolutionary dynamics? Should we expect something like that in ML training runs? How are they governed? How do they function? And then like, what's up with evolutionary novelty? So evolution from time to time sort of finds like sort of distinctly new things. Maybe like suddenly animals have feathers. Like how did feathers come about? That seems sort of hard to explain when we like are like in a very sort of narrow incremental framework of like thinking about evolution. That again might be interesting if we like wonder whether AI systems we develop will eventually develop things like self-improvement or some sort of like notion of modeling itself or things like that. How would that come about? So that's one cluster. Again, I'm a bit only sort of touching the surface area, but yeah, the story here would be something like, can we understand what safe training stories would look like? Cool. I guess we had a bunch of people interested in minds and cognition. So maybe let's say something about this as well. So the core idea here is, can we understand something about the nature and the functioning of how mental states, how cognitive faculties work by looking at human or non-human animals. This is a big space. There's various ways one can carve it up. I decided to just give a few examples of like type of research that is maybe happening in this space. So for example, we might be interested in understanding how motivations and inhibitions are like implemented in the brain. Like for some reason, humans do seem to have things that like work as motivations, or like things that sort of work as inhibitions. Maybe like social instincts. Steve Bryans calls some of this work social instincts, and somehow they're like implemented in the brain. What's going on with this? How does that work? Maybe understanding that could give us sort of design inspirations for like implementing similar functions in AI systems. Another example, I don't think Jan is here. So one of the PIPS fellows this year worked on the question why humans do not do much more wire heading than we're doing. Like, that's sort of surprising. Wire heading, which is the idea that, so I like eating sweet things, right? My brain likes eating sweet things a bunch. Gives me like good experiences when I eat sweet things. My like brain reacts to this. Now, instead of like going out and buying sweet things and eating them, why couldn't I just stimulate my brain directly in a way that gives me the same experiences? And then like, why wouldn't I just like keep doing that all the time? So there would be an example of wire heading where I just sort of short circuit sort of my brain to like be happy, and like maybe like this like for sort of a rational agent that just seeks reward, that seems like really interesting. And if it finds ways of doing that constantly, it will be very happy because it gets lots of the reward that it's interested in. But in reality, like animals and humans just don't do that as much as you would expect. Like
drugs a form of wire heading?
They are, but like we're not all drug addicts. Like there's a bunch of like experiments with like heroin, for example, which like sort of common understanding is that this like highly addictive is like actually really hard to get mice properly addicted to heroin. Like much more surprising than we would maybe expect. So I mean, this is a hypothesis here, and like maybe this is like not in fact correct, but I think like it is an interesting perspective to be like, why does this not happen much more? and like why are sort of brains fairly robust to this thing? Seems interesting. Oh. Another example would be just trying to better understand different cognitive functions, by which I mean things like attention, planning, like search, language, different sort of cognitive functions that are sort of involved in like how humans are intelligent, and like maybe understanding how they relate to each other, maybe understanding how they're like actually implemented. One reason this could be interesting is because it might give us insight into like forecasting capabilities. So rather than forecasting sort of how big will our neural nets be in 2 years from now, we might be also interested in like, well, if our neural nets get so much bigger, like, should we expect there to be like massive improvements to like the sort of things these systems can do? Will there be linear? Will there be sort of like discontinuities? So this might you might want to draw some parallels here to like phase transitions or like shape things that we have like seen in evolutionary theory of cognition in like humans. So for example, tool use seemed to like have been sort of a phase transition-y thing that happened where like human cognition sort of or human intelligence increased a bunch, or like linguistic competence. Why is that? If we understand some things better about that, we might understand just like get a more gears level understanding of what is intelligence even, how does it progress? Again full. Another one is cognitive states. Like, what are cognitive states? Like I mean things like beliefs, epistemic states, models, world models I might have in my brain somehow. Like how are they implemented in my brain? And like why would we be interested in this? Potentially we're interested in this because we might want we might want to get AI systems to tell us what they know while avoiding a range of failure modes. Like it sort of seems simple in the beginning, but like if you look into it, you're like, oh well, like why would it not just deceive us? Or like why, like if you like put lots of pressure on it telling us what it knows, maybe it will like strategically forget things so it doesn't have to tell us things. Like we sort of, what seems simple in the beginning, like turns out to be like hard for various reasons. And like maybe understanding more about how beliefs, roughly speaking, are implemented in the mind will help us make some progress on things like this. There's also maybe a last example to like span the space a little bit. So there's like various problems with like Bayesian learning as implemented in the brain. Like how does an agent reason about the world where like it also reasons about itself as part of the world? It's like part of those models. That's like hard. We sometimes get something we call like model splintering when we like in some sense, Bayesian learning would like assume that you like are tracking all the hypotheses that are to be tracked, and if you like learn something new and like suddenly now you have to track a new hypothesis, like how do you then like Bayesian update based on that? That like runs in that has us run into some problems. How do minds do that? Might be an interesting question. Cool. So some samples of like what we might be interested in understanding with regard to minds and cognition. Mm-hmm.
Sorry, I'm still confused about why you acceded that addiction is actually an alignment failure. Like it seems like if you ask a human, do you want to be addicted? You still would have intent alignment. They would say, I do not want to be addicted. And it seems more like a capability failure. So it's not really wireheading. And maybe this is really a discussion for later, but it seems important.
Yeah. So I think there's interesting things there. I do think like commonsensically, it seems like it seems somewhat commonsensical to say that this is like an example of misalignment because you are in fact foregoing all the other values you have, and then there's a question about like where are values implemented and like how do like we always talk just about values and like maybe there's sort of like differences we want to make between like intents and like other values, high-level values, preferences. There's definitely confusing things going on, but I don't like. I expect like if you could choose to like live in a world where everyone was like addicted to drugs, I'm like not sure this is like the world you would most want to pick. So something is definitely going wrong.
But you would agree that intent alignment is still there. It's like, again, if the entire community, if you ask them, we hate this, we don't want to be addicted to our smartphone, whatever. It's just like, again, a failure of action rather than actual full-blown wire, where you actively want to only wire. You actually forget your real goals, and then you have these new goals.
So you want to say that phones or drugs are just not a strong, like a central case of wireheading? Is that what you're trying to say?
I think the claim was not that like wireheading is an intent alignment failure. I think the claim was that the wireheading is an interesting phenomenon, and understanding why wireheading happens or why it doesn't happen as much as we might expect it to happen in brains is an interesting question to ask. I don't think the claim was made that like wireheading in this particular case situation of like humans using pharmacological or like whatever stuff is yeah.
Okay, cool. I think I definitely have time for one more, maybe two more. So the next cluster I want to introduce is the safe interfaces. What do I mean here? So like backing up a little bit, I want to introduce sort of a little bit of like language concepts here. Let's introduce this thing I'm going to call alignment equation. It's a very simplistic toy example of like how we could maybe think about alignment. What I'm suggesting here is that like simplified alignment is the alignment problem is something like there is an object of alignment. Mostly we like think here about like AI systems. But in fact, like, I don't know, maybe the true answer is that like it's many AI systems, or like maybe it's like something else. But the sort of object of alignment, I'm sort of abstracting a bit of like what exactly is the right way of filling in this placeholder. But there's some object of alignment, and then there's a subject of alignment, which is sort of like the thing we want to align this like highly powerful agent with, the object. Again, that could be human intents, that could be like collective values, that could be something else. And then those object and subjects stand in a relationship to each other. This relationship could be shaped in different ways, and we want to have this relationship as like sort of or aligned, a relationship that is aligned. For example, this could be operationalized as like O acting in service of S, or however you like exactly wanna operationalize it. But this is sort of a very abstract picture of like here is something about like here's how we could think about alignment maybe. And if you take that picture, we can say, well, what are different ways we can shape or define R in the way that we want? And one way is by having O model S so that it can act in service of or like for the benefit of S. And in order for O to be able to do that, it requires some sort of model, some understanding of like maybe what would S want, or like what would S want if it like had like lots of time to think about it, or something like that. That's a possible way of filling it in, yeah. That's probably the way you want to think of it, yeah. Does that make sense? Cool. And then, so there's actually a bunch of like AI safety research that like uses that toy model and then does things like, well, how can we learn human models, like reward modeling? These might be terms you're familiar with, value learning, cooperative inverse RL, stuff like that. These are like methods to like get for O to like get a model of S. However, when we do that, we notice that there's a bunch of risks of failure mode. So for example, it is in fact really hard to differentiate between what represents manipulation and what represents assistance. Like there's sort of a vague boundary there, and like it's sort of like hard to get O to be like very good at like assisting S, but like not in fact like manipulating it or maybe like affecting it in ways that like we maybe don't want anymore. There's like dynamics that push towards like power influence seeking. We might be worried that like O doesn't remain or becomes like non-corrigible. So like it's like holding its model of S maybe not with sufficient epistemic humility. Like does it remain open to the possibility that it's actually wrong about what it thinks S wants? So these are the types of failure modes we run into. And then the idea here would be, can we look at natural systems and maybe gain inspirations about how we could get O to model S in a way that like avoids these failure modes? Or on the other hand, maybe we can like look at natural systems and like notice more failure modes, like notice new ways this could go wrong, and that seems like also good to know. The two main sources I want to highlight here. So the first one I'm not going to go into because I already talked about like mind stuff, but like in general, just quickly noting that there's this concept, this phenomena of theory of mind, which like humans and non-human animals have from each other, like that actually like a lot of our interactions are based on. Like if I cross someone in the corridor, the reason that, an important reason for why we don't bump into each other predictably is because I'm somehow modeling the intentions of the other agents, that it like might, you know, whether it will pass me at the right side or the left, and we sort of can coordinate based on that. That would be an example of theory of mind. Various other examples. So like human and non-human animals' minds actually implement theories of mind, which like looks very similar to what I described before. How does this happen? What can go wrong? Like maybe new ways this can go wrong, but also why is this like fairly robust or like doesn't lead in many cases to like all the failure modes we mentioned before. The second source of inspiration I want to focus on, and that, because it's maybe a bit like more speculative, but also maybe a bit more interesting or a bit more new, is that, well, maybe we could claim that like a bunch of social institutions do a similar thing, like have something like models of humans. And like I want to hold this very loosely, like maybe it's like models of humans suggest sort of something somewhat explicit or like encoded somewhere or whatever. Like not sure it's like implemented in this way, but like here are a few examples of like how whether the relationship is like somewhat similar. So like welfare economics. There's some notion here of like the set of institutions that is like trying to like bring good things to like the aggregate society needs to model somehow like well-being or like what it would mean for those agents to like be well, what they want. Otherwise, it couldn't serve its purpose of like promoting welfare. How does that happen? I'll mention this in a second. Another example would be legal theory, contract theory, where like, in fact, we have lots of contracts in this. Like, contracts are really useful in terms of like being a society that functions. But contracts are always underspecified, right? Like we never write a contract that's like perfectly specified as to what we want. There's always like there's space for interpretation, but at the same time, like they don't constantly fail in a horrendous way. So somehow we have like embedded some way of like modeling or understanding like what they sometimes would call legal intent, like an intent that we can't fully specify, but that it's still like the sort of the semantic value of it is still carried over like fairly well. Kind of interesting. Like somehow it gets around some of the problems we're worried about in AI because we can't specify what we want fully. And then the last example might be an example of like this idea of corrigibility, like remaining open to like the subject updating what it wants or changing its mind about what it wants. So like maybe just like getting a better understanding of what it wants. So like in firms or like in the market in general, it looks like markets sort of remain corrigible to changes in consumer demand. So it's not in fact the case that like a firm sort of like notices, oh, like everyone is interested in iPhones now, and then like just continues putting out iPhones for forever. It is in fact the case that like the consumers like change what they want over time, and that like firms remain corrigible or like remain sensitive to that. And in AI language, we're sort of like, well, they might remain corrigible. How's that implemented? Can we learn from that? For all of these cases, like there's strong reasons why you might think, oh, the parallel just breaks because like we're dealing with much stronger optimizers, or we're dealing with like systems that like compute much, much faster than like any of these systems do. And I think these are super valid points. And but then I think it's like can still be interesting to check like when and how does the analogy break exactly? Can we still get inspiration or like insight into how the system functions? I'm definitely open to like, you know, someone might look into this and be like, yeah, we just like, there's not much to learn because like the assumptions in the two cases are actually too different, but I think it's like roughly worth like looking into. So. Okay, so we have sort of 10 minutes left, and I want to make sure we get to questions. So I'm going to skip ahead. If we happen to have more time in a bit, maybe we can do more. So yeah, 3 more that we didn't. But let me wrap up before we get into questions. So there's sort of 4 things I wanted to get across in this talk. One is going back to like the beginning, the high-level stuff. I kind of want to motivate what I call a philosophy of science for AI alignment. This is like this entire thing around like, well, what's the shape of this problem even? Like, what are different ways we could be making progress? Can we develop more different approaches to making progress? Because like currently we're still pretty confused about what actually works here and like whether it can work. And I think like methodologies and perspective of philosophy of science are sort of like relevant here. And then related to that is the idea that the idea of having more epistemic pluralism within AI alignment. By epistemic pluralism, here I mean specifically like sort of more different epistemic strategies, epistemic bets for making progress beyond, for example, like just like technical AI safety that works with ML and CS that is like clearly good and clearly what we should be doing. But also I think we like there's like good arguments to make that we're like pretty confused about various like very fundamental notions that are being invoked when talking about the problem, and like potentially getting sort of more deconfused about these basic notions will be able to like unblock some process. And I think for that, a decent bet is to sort of look elsewhere and see whether we can like find elsewhere more conceptual clarity. And then I dived into sort of the natural systems approach a bit more. The underlying idea here is also like to get sort of more diversity of competencies, diversity of epistemic perspectives to bear or to like, to bear or to be leveraged for progress in alignment. I think this is like currently not really the case because there's like inferential distances to cross. Like, why would someone who studies like evolutionary biology work on AI alignment? Like, how could they do that? How can they make sense of it? I think there's like, I am in favor of a push for people with more epistemic perspectives to come into working on problems in alignment and AI strategy. And then lastly, you've sort of seen early stages of like trying to just develop a better overview of like, well, but then concretely, how can we learn from natural systems? Like, what are avenues that seem like interesting to look into to maybe also sort of scale research in this space? That's the aims I had for the talk. You might have heard about this already. It's like most of this work, of this thinking comes out of this initiative, PIPS. So we have been running a summer fellowship this year. There's several fellows actually here, so if you want to talk to them, you can. They're usually friendly. You can talk to them. Usually. So yeah, PIPS is sort of trying to facilitate more of this research, or like test whether like this is actually worthwhile, right? Maybe in 2 years we're like, no, nothing useful came out of this. Clearly, all you guys go study ML. I currently don't think that, but like maybe we'll learn this. Yeah, so that's me. And now we have something like 10 minutes for questions, if there are any.
Thank you for your talk and for the comprehensive overview. Can you hear me? Yes. My question is from the topics that you have presented, which is the area that you see that the AI alignment is most kind of lacking or would need most kind of to look into? Or if you can't answer this, what would be your approach to find out?
Yeah, I'll just go back to the sort of overview slide, which might be a bit helpful. So I think there's like maybe different sort of sub-questions here. So like one might be like, what epistemic perspectives, what sort of like areas of expertise are most lacking? And then there might be a different one of like, which sort of approaches or like clusters do I think sort of maybe address, like are most likely to like unblock research progress or something. The answers to that are like related, but also like slightly can come apart in some cases. I mean, overall, I don't know the answer. I have some guesses. I think there's like work in this cluster on trying to understand autonomous behavior and agency. That like where like the hope is to like make some very basic like deconfusion because like we constantly, when talking about AI alignment, have some notion of like, okay, cool, but like what we're worried about are really powerful agents, like really powerful, the sort of things that like, end up having goals and end up sort of doing things in ways that sort of elude us a little bit. Like we don't have sort of very mechanistic understanding for like why they end up doing what they do or something. Like that's sort of like the thing we sometimes call agency. And that is confusing. That is where like a lot of risks come from. And we don't have good language for talking about this. And I do think like other fields have the potential to like provide useful language around this. Like that's an example. I mean, maybe this is a bit personally biased. Like I think you shouldn't, I don't know, I think you shouldn't take too much away from this because like I only just have my specific epistemic perspective. But I think another cluster of things I'm interested in is, I don't know, the short version of this is something like, can we get intelligent systems or processes that aren't like consequentialist or like that are limited in their consequentialism? And by consequentialism, I mean here something like the sort of means-end reasoning or like doing planning in order to like bring about certain consequences. And like that sort of like thing, that cluster of thing is related to a bunch of like risk stories, like convergent, instrumental convergence, like power-seeking stuff. Like a lot of AI risk stories will like pass via these phenomena. And there's like, and they sort of seem to be related to like being a consequentialist agent. And then there might be a question whether like, well, are there natural systems that like are intelligent or like exhibit some sort of like intelligence or general problem-solving capacities that aren't consequentialists? Or do we see examples where like the functioning of these systems bounds the consequentialism of like different agents within the system? I think there are examples of this, or like I think there are plausibly examples of this, and I'm like pretty interested in understanding that better. So this is like some of my research interests. I think like where are we lacking in most of this? Like I think we have like a sort of few brain sciencey. Like I think like the analogy to like brain sciences is like a bit more natural because like neural nets are sort of originally even inspired by brains. Like that feels like somewhat natural to like most people in AI. I think like shyly people are like, yeah, I guess like evolutionary theory can give us insights. I think there's like inferential distance is like yet much bigger in other fields studying social systems. I feel like studying complex systems is like not yet very, very represented. I think philosophy of science have things to offer. And these fields are like not particularly represented.
Thank you. It was a longer answer than expected. Cool.
Yeah, thanks for the brilliant talk, Nora. The more I'm exposed to this vision, the more impressed I am with the thoughtfulness behind it. My question is around, you mentioned this before, around the firm example of it might not hold for strong enough optimization pressure. So I'm really curious if there's like some pattern or shape of responses that, like, to me that feels like usual. Like the clear case for the firm example is still trade with the consumers, the strong optimizer, use your atoms or whatever.
Yeah.
So I'm wondering if there's like a shape of response you have towards this kind of objection.
Yeah, I think this is a good question. I'm not sure I'm going to say all the things that like one would ideally say. I think one thing that I think is worth saying is something like, I think there is, in fact, a difference between idealized agents and real agents, in the sense that so we can reason about idealized agents. We might reason about them in the sense of like they're sort of unbounded on a bunch of dimensions, etc. But as soon as you like physically implement a system, it like ceases to be an idealized system. It becomes a real system and it becomes bounded in some ways. And then there still remains a big question as to like, is it sort of sufficiently bounded for like to be interesting, or to be of practical relevance for us, right? Like we can imagine a system that is like bounded, but it's like bounded somewhere so far away. It's like sort of so far away that like for all practical purposes, we still face all the AI risks or something. But I think that is the question. It is a question of like how much will they be bounded on what dimensions, and where they are bounded, like does that sort of that delta, does that offer sort of loopholes for sort of alignment strategies? So I think that is one thing. And then, so that is specific to alignment strategies. And then I think another sort of like hope or like sort of epistemic purchase you might hope to like make from these strategies, or like a bit more sort of just like better gears level understanding of like phenomena we're interested in, like just better language around things we're interested in, and like that's just like having the right concepts or like having the right language to talk about something, just like historically is like makes a difference in being able to like think clearly about something. And I think that might be another sort of cluster of, or like another category of like insights we might hope to get from this.
So just to quickly clarify, the first point was physical instantiation, bounce agent. The third point was we might develop better languages. What was the second point? Can you clarify again?
I'm not sure. I don't think I gave a second point. I think these are the two things I gave.
Okay, cool, thanks.
Cool. Other questions?
Last chance. We have 1 minute left, or we can leave for the break 1 minute early. No one, in that case, thanks Nora for the talk and the discussion.